Welcome to Watch This Space. I'm NASA Administrator Jim Bridenstine. Today I want to start by celebrating the amazing accomplishments of our Opportunity rover on Mars. Originally planned for just 90 days, Opportunity explored the red planet for an astonishing 15 years, along with its sister rover, Spirit, which also far outlived its original mission. Opportunity brought us new discoveries about our planetary neighbor that will inform future robotic missions and even human missions to Mars. We gave an update on the mission February 13th at our Jet Propulsion Laboratory.
Last night, the team made its final planned commands. At the time, part of the team went up to Mission Control to send up more commands to ask the rover to respond. One-way light time is about 13.5 minutes. It took 13.5 minutes to get a signal up to Mars. And if the rover did respond, it would take another 13.5 minutes to come back. To find out more on what the outcome was from last night, I'd like to introduce you to the panel right now. We begin with introductions. Our JPL Director, Mike Watkins, the NASA Administrator, Jim Bridenstine, and also the Associate Administrator, Thomas Zurbuchen. Thomas, we'll start with you.
Thank you so much. I was there yesterday, and I was there with the team as these commands went out into the deep sky, and I learned this morning that we had not heard back, and our beloved Opportunity remained silent. It is therefore that I'm standing here with a sense of deep appreciation and gratitude that I declare the Opportunity mission as complete, and with it, the Mars Exploration Rover mission as complete.
This is a celebration of so many achievements. And I'll just start by saying, when this little rover landed, the objective was to have it be able to move 1,100 yards and survive for 90 days on Mars, 90 sols. And instead, here we are 14 years later, after 28 miles of travel, and today we get to celebrate the end of this mission. So it's an honor for me as the NASA Administrator to come out here to this amazing facility with so many amazingly talented people to say thank you for your great work, not just for our country, but for the science that people are going to be benefiting all over the world. They're going to be benefiting from this science for years to come.
Spirit and Opportunity may be gone, but they leave us a legacy. And that's a legacy of a new paradigm for solar system exploration. A robotic geologist on Mars and an integrated science and engineering operations team here on Earth all set out together on a mission of discovery. They didn't know what they would find. They didn't know which direction they would go, sometimes from one day to the next. And they made it work. And they made it work longer than any of us thought possible by both brilliant scientific deduction of where to go and brilliant engineering to keep the rovers alive.
Confirmation of a safe landing. We're seeing it on the LTP.
Opportunity hit a hole-in-one when she landed. The airbag system rolled into the small crater called Eagle Crater. And when the rover first turned on its cameras, it saw that the rim of the small crater was lined with exposed bedrock.
So we took out our microscope for the first time and we took a picture, and the surface of Mars at that location is littered with an uncountable number of little round things.
That were called blueberries because they looked like blueberries in a muffin. What we discovered was that those are features that form in water, and they were a really definitive sign that there had been liquid water on the surface of Mars sometime in the past.
After we left Eagle Crater, we went to Endurance Crater, and that's the crater we drove down in. And there we did what the geologists call an in-sequence stratigraphic section, which is essentially reading the chapters of the Martian history book in reverse order.
That rover became a stratigrapher. First time you had a stratigrapher on Mars. We knew we wanted to go after Endurance to Victoria.
We put pedal to the metal and we started heading there, tens of kilometers away, We had to literally surf across these dunes of wind-blown material, and the rover got stuck in one of those. We had to get the rover unstuck. What we found is the best way to get it out is just to put it in reverse and gun it. The rover eventually popped out. And so we changed our driving strategy. So we recognized these ripples as hazards. We get to this giant half-mile diameter crater, Victoria Crater, and we want to figure out, gee, how can we go into this thing?
All of a sudden we got high-rise images. We could see the rover in the image.
And that was the very first image that we got from space showing one of our rovers.
We spent a year scouting the edge of that crater to decide where we wanted to go in to get the best stratigraphic section.
We found a place to go in, and we drove down in, and we spent about a year inside Victoria Crater.
The science team was really excited about the idea of driving to Endeavour Crater, over 20 kilometers away. This is a long drive to do. It was going to take multiple years, but they decided to do it anyways.
There were too many of these dangerous ripples in our way, and we actually had to take this circuitous route that at times took us away from the crater, only to then cut back and then approach it more directly.
And then we pull up to Endeavour Crater, and all of a sudden there's all these new things to look at.
When we first discovered the homestake vein, it was this very, very bright linear feature. It turns out that there was a big gypsum vein, and we see these gypsum veins now all over. So it was our first taste of what is a really important process on Mars.
We were driving to a valley, and along the way there, we realized that right about the point where we were about to get to this valley, that was when we were going to cross the marathon mark. So we said, well, that's cool. We're just going to name this valley after that, call it Marathon Valley. That was when we reached the distance of a marathon, 26.2 miles on another planet. We continued driving through some slopes down a little bit on the interior of the crater rim until we came back out so that we could continue on to the next valley, Perseverance Valley,
where the rover was exploring when we lost contact.
We said we're going to operate this vehicle until the day where we can't, and that's exactly what we did, and I'm really proud.
We've set a foundation that will serve as the basis for future exploration.
NASA is committed to sending humans forward to the moon in the next decade, and this time we're going to stay. We want to establish a permanent, sustainable presence beyond Earth as we push farther into the solar system. To do that, we're going to need the next generation of lunar landers. We've already kicked off that process, and we held an industry day at NASA headquarters on February 14th to discuss the next steps. Today, we're highlighting a broad agency announcement about putting humans back on the surface of the moon. And of course, you're here today because one of your company is interested in participating in this activity. And we're very interested in your participation in a way that maybe historically NASA hasn't involved commercial industry the way we're involving it today. And I'm going to tell you why we're doing it. The President issued what we call Space Policy Directive 1. It says that we're going to go back to the moon. And I like to say that we're going to go forward to the moon. We're going to go to the moon in a way that we've never gone to the moon before. We're going to go with international partners. We're going to go with commercial partners. And here's the key element. We're going to go sustainably. In other words, this time when we go to the moon, we're going to stay. So we're not going back to the moon to leave flags and footprints and then not go back for another 50 years. We're going to go sustainably, to stay with landers and robots and rovers and humans. And that's what we're here to talk about today. We're going to put humans on the surface of the moon. We're going to build an architecture where we can go back and forth again and again and again. Another piece of Space Policy Directive 1 is actually using the resources of the moon. It was discovered back in 2008 that there was potentially water ice on the surface of the moon. In 2009, NASA did a study, and we've now discovered that there's hundreds of billions of tons of water ice on the surface of the moon. So, new American policy, we're going to utilize the resources of the moon. Water ice represents oxygen, air to breathe. It represents water to drink. In other words, life support. But it also represents rocket fuel. Hydrogen and oxygen is the same fuel that powered the space shuttles. So all of that is abundant in hundreds of billions of tons at the poles of the moon. So we're going to go back to the moon. We're going to go forward to the moon. We're going to go with international partners and with commercial partners. We're going to go sustainably. We're going to utilize the resources of the moon. We're going to retire risk. We're going to improve technology. And then we're going to take as much of this as possible and replicate it at Mars. And this is all part of the President's Space Policy Directive 1 that we here at NASA are charged with moving out on. And friends, we're moving out very quickly.
This is the beginning where we really Jim and I wanted to kick off and kind of show you the bigger architecture, the things we're planning, and how we think this is very different than what we did before when we went to the moon with humans. This is really sustainable. This is going to be fast. We're going to need the best and brightest from you in industry. We're going to need the best and brightest from the international partner community to pull all this off. And we've got a great plan to do this. It all fits under Space Policy Directive 1 with sustainability. It fits under that in cooperation with industry, commercial partners, and also with international partners.
I want to thank the entire NASA family for their hard work as we push the boundaries of human exploration, as we make new discoveries about our Earth, our solar system, and the universe beyond, as we improve flight, and as we innovate new technologies. It's an exciting time, and there's a lot on our plate, but I know we'll continue to rise to the challenge. Thank you again for watching. Check out nasa.gov/watchthisSpace and follow me on Twitter @Jim Bridenstine. Ad Astra.